A derivative answers a simple question. If I change one input a tiny bit, how fast does the output change? For example, if f of x equals x squared, the derivative is 2x. At x equals 3, that means a small increase in x makes the output grow about 6 times as fast. Real life rarely depends on just one input. Profit depends on price and advertising. Temperature depends on location and time. Volume depends on radius and height. Now the output depends on several knobs at once. A partial derivative keeps the same idea of change, but focuses on one knob at a time. It measures how the output changes when you change one input slightly while holding all the others fixed. That phrase, holding the others fixed, is the entire point. If a function depends on x and y, the partial derivative with respect to x asks, what happens if x moves a little, assuming y stays the same? The symbol looks like curly df over curly dx, but the symbol is less important than the idea. Computing one is straightforward. When taking the partial derivative with respect to x, treat every other variable like a constant number. For f of xy equals x squared plus y cubed, the partial with respect to x is 2x, because y cubed acts like a constant. The partial with respect to y is 3y squared, because x squared acts like a constant. A useful picture is a hill. The height depends on your east-west position and your north-south position. One partial derivative is the slope if you walk east-west only. The other is the slope if you walk north-south only. In practice, partial derivatives measure sensitivity. A large value means the output reacts strongly to that input. A small value means that input barely matters, at least near that point. Take a cylinder with volume V equals pi r squared h. The partial with respect to radius is 2 pi r h. The partial with respect to height is pi r squared. Plug in numbers and you see that a small change in radius usually affects volume much more than the same change in height. That idea drives real uses. Engineers track how heat or stress changes across space. Economists study marginal profit by changing price while holding other factors fixed. Optimization and machine learning adjust many parameters by following partial derivatives to reduce error. In short, a partial derivative is a one-at-a-time rate of change. Change one thing, freeze the rest, and see how much it matters.